Next, we will be talking about. So I think this whole set of entropy is over. We have done dou S by dou T at fixed V, dou S by dou V at fixed T, dou U by dou S by dou P at fixed T, dou S by dou T at fixed P, dou S by dou P at fixed V, dou S by dou V at fixed P. Right? All are over. Now we go to internal energy. Can we have the same 6 derivatives, similar kind of 6 derivatives for internal energy? So let's look at. Now we can apply this formula. We have got another 6 set of formulas with you. Earlier you had 8 definitions, right? 4 Maxwell's formula and 4 definitions. Now we have got 6 more formulas, so we are now happy with. We have 14 formulas. We can happily apply them and get the derivatives for internal energy. Okay. So we know that du equals to Tds minus Pdv. Okay, and from here we know dou U by dou S at fixed V is temperature, and from here we know dou U by dou V at fixed S is minus pressure. We want to find dou U by dou V at fixed T first. Dou U by dou V at fixed T. We know that, start from first principle, U equals to U hat SV, and we have to find out finally U bar Vt, correct? What's the procedure? S is the function of V and T, we all know. You can happily apply them. So it is U hat S hat Vt V to get it. So we will tell the procedure. Steps. Next step, ds equals to du equals to we will tell the procedure. D equals to, yes, the band. Dou U by, again you are doing mistake. Dou U by dou S at V constant V. Yeah, dV, just like our basic formula, right? dV, and then we have the with respect to V at constant ds. That will be ds. Sir, the first term is dou U by dou V at constant T, dou U by dou S at constant V, dou S by dou V at constant T, dou U by dou V at constant S, dou V by dou V at constant temperature. Right? Dou U by dou V at fixed S is minus P. This is 1. So you got minus P here. Dou U by dou S at constant V is temperature. Dou S by dou V at T is beta by kappa. What is that? Beta by kappa. So you got the formula dou U by dou Vt is T beta by kappa minus P. T beta by kappa minus P. If I want to know for ideal gas what is my dou U by dou V at T, you can say tell me, so for ideal gas PV equals to RT. From here you can calculate beta. From here you can calculate kappa. What is beta? From ideal gas, beta equals to 1 by V dou V by dou T at constant pressure. So from here you can calculate V equals to RT by P and dou V by dou T at constant pressure, which is R by P. So we can write here 1 by V R by P. Kappa is minus 1 by V dou V by dou P at constant temperature, and from here you can calculate, you can put it there and you can get the final answer. That's all the sample calculation. So if I want to know for ideal gas how this quantity is changing internal energy with respect to the volume at fixed temperature, we can easily calculate. Same thing we can for other quantities. Next is dou U by dou T at fixed V, you know that. this CV. So it is done. So TV series for U is done. Next we will go for dou U by dou P at fixed temperature. Next we go for dou U by dou P at fixed temperature. Dou U by dou P. Dou U by dou P at fixed temperature. That means we have to write U as function of pressure and temperature. U as a function of pressure and temperature. But we all know that U is the function of SV. Okay? We all know that S is the function of P. We have to get U bar PV, sorry, PT. So this we can say that U hat S hat PT, V equals to V hat PT. Here we will apply real chain rule of differentiation. All are acting. Earlier only this was acting, this was like constant. Okay, now full chain rule of differentiation we have to apply, and who will help me? Who will help me to do that? du equals to who will help me? Any hands please? Yes. Can you please speak louder because I cannot hear? Constant D, what is that? Multiply plus dV. Next step, can you tell the next step? Yes. Dou U by dou S at constant V at constant temperature at constant S dou V by at constant temperature, right? Okay, so you got all the expression. Dou U at dou S constant V is temperature, right? Dou S by dou PT, we have done it earlier. Dou S by dou PT, dou S by dou P, yes, minus beta V, plus dou U by dou V at S minus PT, dou V by dou P at constant temperature minus kappa V. So we got the answer. It is P kappa V minus T beta V. And if I want to know for ideal gas, what is the expression? So if we say this is my temperature, it is function of temperature, pressure, volume, whatever. So for ideal gas, we can calculate, or for any real gas, it is possible to calculate dou U by dou P at constant temperature. Is it clear? Next is dou U, dou T at constant pressure. Remember that we know dou H by dou T at constant pressure. Now I am asking dou U by dou T at constant pressure. How to proceed? So it is saying that U is U bar Tp. Now tell me how to proceed. Pardon? Yeah, how to proceed? Yeah, so U equals to U hat SB. Okay. U equals to U hat SB, which will be leading to U bar Tp. What's the way? U hat Can you give me the final expression? Dou u. Okay, so I'll ask you to get me the final answer because now you're expert. Now you're expert to calculate. So give me the final answer. Dou u by dou p at fixed p. What's the final answer? You got it. Okay. Cp minus beta Vp. Correct? Cp minus beta Vp. Okay. So U as function of pressure and temperature, both the derivatives have been obtained. Last thing is remaining. U is the function of pressure and volume. U is the function of pressure and volume, and two derivatives will be coming in your mind. Dou u dou v at fixed p and dou u dou p at fixed v. So first we'll go for dou u dou p at fixed v. First we'll go as dou u dou p at fixed v. How to approach? Okay, you are saying USB. That is a good approach, but if you think properly, another route is also there. We have already got it, right? You have to get finally PV. So this is U hat P T PV. You can do that way also. Then you go back home and do it. What are you getting here? If you do this, I'll give the answer. That answer I have, I'll give it to you. Dou u by dou p at fixed b by this path, which you will be getting as CV kappa by beta. Let's see here what you get. Let's see what you get here. From this path, what will you get? Dou u dou p at fixed b equals to dou u dou p t, then dou p v plus dou u dou t p dou p v. Am I correct? Yes or no? Yes. 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 Okay, good. So all are agree. This is 1, right? What is dou u by dou p at fixed t? Which is minus beta Vt plus P kappa V plus dou u by dou p at fixed P. We have already done. C dou u by dou p at P Cp minus plus Cp minus beta Vp. Dou t by dou p at fixed V. Dou t by dou p at fixed V. Can you get it? Dou t by dou p at fixed V. Can you get it? From implicit function theorem. Pardon? Yeah.
From Maxwell.
Yeah, Maxwell relationship can you get?
A by beta.
A by beta. Kappa by beta. Sorry. Correct? What are you getting finally? job is that you go back home and try to see whether you are getting the same formula. Assuming ideal gas, Cp minus Cv equals to R. Time being, assume ideal gas. Later on, when you know all the equation of state, you will see that whether you are getting the same. You should be getting the same one. Now I am showing you different routes, different way you can evaluate the derivative, right? Similarly, you can actually also get dou u by dou v at fixed speed. Dou u by dou v at fixed speed. U is the function of Sv, and your final objective is U is the function of Pv, and you have to write U hat S at Pv V and going that, and so what did you get? Dou u dou v at fixed speed. You can try it out other part. Two ways you can do that. You know that. Other part you can go back home and do it. So what will be the final answer? Dou u by dou v at fixed speed. From here, final answer. Dou u by dou v at fixed speed. Final answer. Yes, sir.
Cp by
beta v minus
P.
Go. Yes, correct. Cp by beta v minus P. So dou u by dou v at fixed speed, Cp by beta v minus P. Okay. So U series is complete. 6 derivatives. Next comes H series. Enthalpy. Enthalpy is very straightforward because we know that H equals to U plus Pv. Okay. So you all know the variation of U and variation of. So if I want to know dou H by dou Pt, dou H by dou Tv, dou H by dou Vt, for example, I won't do it all details. It will be dou U by dou P at fixed T plus P dou V dou P at fixed T plus V dou P by dou P at fixed T. So dou H by dou P at fixed T, what's the answer? I will do all things. Dou H by dou Pt, what's the answer? Dou H by dou Pt, dou H by dou P at fixed T. Any answer? Just yeah. Yes, sir. You are correct. V into 1 minus T beta. Dou H by dou Tv. Do the same way, same approach. I just want only this 3, and last one I want to have dou H by other things you can try at home. Only 4 is sufficient at this time. Dou H by dou Tv. Dou H by dou Tv. Dou H by dou Tv. You can give me answer. Dou H by dou Tv. dou H by dou TV. Yes.
CD minus
C
CD
CV
minus V beta by kappa
is not minus plus. Okay, okay.
plus beta by kappa.
Yeah. Now dou H by dou V at fixed T. 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 Yes, is it done? Dou H by dou V at fixed T. One by kappa. Yes, madam. T beta minus 1 by kappa. And similarly, you can have dou H by dou P at fixed B, dou H by dou V at fixed P. And that is question mark. You can go back home and do it. Next, I will move to the Helmholtz free energy set. So, similarly, you can make all derivations. These are very straightforward. Next, we go to Helmholtz. Helmholtz free energy, which is A equals to U minus Ts. Helmholtz free energy is defined as U minus Ts, and now we can see that all the derivatives can be evaluated because we know dou U by dou U series, we know dou S series, we just plug it in and get all the Helmholtz free energy set. Okay, so like that you can derive all the free energy set of Helmholtz free energy set for the partial derivatives. Okay, so next we will be going to the Gibbs free energy. Gibbs free energy, which is G equals to U minus Ps plus Pv, or you can write this as U H minus Ts. So since we have all set of H is there, you can calculate the all derivatives of G set from the H and S set, right? So those things you can go back home and try to do it. Now I'll ask you to calculate Cp and Cv for any real gas. If we don't know so that expression now we'll be using for all those expressions to see whether they're equal, two paths. So we'll be doing Cp and Cv relationship for any gas, not the ideal gas or not some other specific gas. So relationship between Cp and Cv. Relationship between Cp and Cv. How to approach? Let's see how you can think to approach. With the formula what we have, I don't have anything extra. Now we have derived all the formula. Go back to your class notes and tell me this is the way I want to approach. Remember that I want to express Cp minus V, Cp minus Cv as function of properties.
So we can start from entropy, like S is a function of Tv. from there we can start.
We have to define. We have to get the definition of CP, CP, and C.
Yes, sir, from there only we can.
No, but if I start the left hand side, CP minus C, that's the way I always like derive things, right? What's the next step? That's the way I always look at. If I want to start deriving something, I have to look at left hand side.
E derived by
CP is what?
Dou
H you will do, or you write dou S by dou T at P
into T
minus dou S dou P constant.
OS by dou T. OS by dou P constant T.
And beta by kappa. Okay. Look at S equals to what you want to do. S is the function of P and T. Cp and, or you can actually do S equals to S function of B and T. Both ways. This is the quantity you have to derive. We have to keep it. I will just come back to this expression later, not now. We have to get the expression for dou S by dou P and dou T at fixed P into T, and T into dou S by dou T at fixed V. But we have to get that quantity.
Sir, from DS equal to TDS equal to CVD, what does we will get dou S by dou T and constant V to C, TC.
Okay, let me give you some step. Dou S by dou V at T. What can I write? For that purpose, we have to write TV comma T. Okay. Sorry. Dou S by dou T at fixed. Otherwise, you won't get CV, right? I want to have CV here. CV by T. This is nothing but CV by T, right? CV by T. CV by T equals to what?
Dou S by dou T and constant V.
Dou S by
Dou T and constant V.
dou S by dou V, dou P
And constant V.
and constant V. Why V?
It's a T. Constant T.
Forget about this one. If I want to write from here, fundamental, what should I write? Did you understand this one? I'm asking you. Do you understand? I'm helping you. Don't feel that I'm harassing you. Okay? I'm just here to help my poor guy. My role is the teacher to help you. If you want to learn, you can do. Otherwise, I can skip. Is that okay if I ask you to, whether you can understand? So, what's the next step? If you don't know, no problem.
Dou S by dou P and constant T.
Dou S by
Dou P and constant V.
constant
T.
T.
Dou P by dou T and constant V.
Then
Dou S by dou T.
dou S by dou T,
Constant T.
constant P,
Dou T by
dou T by
dou T and constant V.
dou T by
Dou T and constant V.
constant V. All of you agree? Okay. This is 1. Dou T by dou T V, 1. Dou P by dou T V, how much it is coming? Beta by? How much it is? Dou S by dou T at constant T? Minus? Minus beta V or plus beta V? Plus, this is Cp by T, no? Am I correct? Cp by T minus, or if you write Cp by T minus Cp by T, this minus will be plus, right? It will be beta V beta by kappa. So Cp minus Cv, that expression, actually you don't need to write here, directly it is coming. Cp minus Cv, which is T beta square V by kappa. Now can you prove it is R for real ideal gas? I'm going to prove, we have not proved it. How to prove this is equals to R for ideal gas? How to prove?
EV equal to RT relation we can.
That is okay. So first you have to evaluate this and this. T and V cannot do anything. Okay. So PV equals to what T? Beta is what? Beta is 1 by V, dou V by dou T at constant P. So from here we can get dou V by dou T at constant P, which is R by P. So this R by PV. Kappa is minus 1 by V, dou V by dou P at constant T, and dou V by dou P at constant T is minus RT by P square, which is 1 by V RT by P square. Okay, so we have T V, where first term is R by P square V square, kappa is R T V P square. This will be did you prove like this earlier? This is the more formal way to prove Cp minus Cv equals to R. This is a more formal way. And for your expression, for your problem, where you got Cp and Cv, you have to substitute only this one. So Cv, if you got Cv, if you want to get in terms of Cp, you can write Cv equals to Cp minus T beta square V by kappa. If you substitute, you get the same expression. So please note down that part in your answer book, so that when you get your answer, when you get things done, so you can get the final answer when you are putting it. So I think these are all the beautiful proof. Cp minus Cv equals to R from the first principle. Okay. Next, Cp by Cv. Cp by Cv. We know for this ideal gas, I think gamma or something. But what is actual? Now we know all these rules. How can we approach? Let's see Cp by Cv. Cp by Cv, which is dou S by dou T at fixed P by dou S by dou T. 1 by T will get cancelled. How to get that gamma? That gamma is right for any gas, I think. Just check it out. What is this gamma? What is this gamma? Do you remember? We say Cp by Cv equals to gamma. They say for ideal gas, 1 point some value is there, right? What is this gamma? We will see the gamma, how it is coming from our main definition. Now we know the basic principle. From here, what can you do? Can you do anything else extra? Dou S by dou Tp, we can use implicit function theorem, which is minus dou P by dou T S by dou P by dou S dou S by dou T at fixed B minus dou V by dou T at fixed S by dou V by dou S at fixed temperature. Am I correct? Implicit constant theorem. Yes. Equation number A. Equation number B. If you divide equation A by B, what you get? Cp by Cv. Divide equation A by B. You get what? Cp by Cv equals to I'm just giving you the final expression, just see whether you're getting or not. Yes or no? Yeah, one person got. I got at least one or two. Is this correct? All of you got it? One person only got. Devayan sir. Got lost, huh? Got it or not? Check it out because I am just pausing it here because if I go fast you may not be able to understand. That's why I am pausing it here. That's why I am pausing it here. Got it? Okay. What is this term? Dou V by dou P at constant T. Can you write in terms of any property? Not beta, kappa. Not gamma, kappa. Kappa is isothermal compressibility. What is kappa defined as? Minus 1 by B dou V dou P at T. There is some process called isoentropic process. For isoentropic process, AC is constant, entropy is constant, right? For isoentropic process, entropy is constant. Similar to isothermal compressibility, which some people refer as kappa T, I can refer to another compressible process called kappa S, which is minus 1 by B dou V by dou P at fixed S. That is called isoentropic compressibility. That means what will happen here? What my ratio will be? What my ratio will be? Kappa T by kappa S, and that's your gamma. So now we know what is this gamma, which is the ratio of isothermal compressibility to isoentropic compressibility. So Cp by Cv gamma, now gamma is very clear to all of you, which is nothing but isothermal ratio of isothermal compressibility to isoentropic compressibility. Okay, clear? Now, many books you might have seen, the Cp and Cv, they are not constants. They are the function of pressure and temperature. If it is a function of pressure and temperature, with the available formula, can you get the function of pressure? Cp is a function of pressure and temperature. So let's look at the new topic. I will finish in 5 minutes. Just I want to introduce here and then go. Effect of pressure and volume, or effect of pressure, temperature, whatever. Effect of PVT on Cp and Cv. And generally speaking, when you write the expression for Cp and Cv, we always write in terms of entropy. It's better to formulate. Otherwise, if you write in terms of U and H, for example, people have tendency. Cv is nothing but dou U by dou T at fixed B. Cp is nothing but dou H by dou T at fixed B. I will write different way. I will write Cp is nothing but 1 by T dou S dou T at fixed B, and Cv is 1 by T dou S by dou T at fixed B. Cp by T. So that's how I write. This makes my life simpler and I can do a lot of derivations based on that. Now, if I say effect of pressure, that means I want to evaluate this quantity, dou Cp by dou P at fixed temperature. One question I'm saying that, why I'm not writing volume? Volume is also another variable, right? I could have said dou Cp by dou P at Tv. Why I'm not writing that? Let's see who can give me the answer. I should have written Tv, no? Because I have pressure, temperature, volume. Whenever I wrote, all the derivations I wrote, only one. Why?
If it is T and D, T will be constant.
No.
Pressure is constant.
I am not saying this says that. What does it mean? It says that F is the function of temperature, pressure, volume. That may be Cp. F may be Cp. My point is, as I don't write, I write T. Why? Pardon?
Independent of T.
Okay, your answer is partially correct. When I say PV equals to RT, it says that you can also write as PV equals to RT by P. It says that if T and P are fixed, V is automatically fixed. If T and P are fixed, V cannot be changed independently. So my independent variables are T and P. And that's why I write this equation as V hat Tp. Because these two are independent variables. So this is my dependent variable. Right? Okay. So that's why when I say this kind of stuff, that means this will talk about independent variable. If I say T and P, V cannot be independent variable. V is dependent. Similarly, if I say TV, then P cannot be independent variable. Because this expression we can write as P equals to RT by V, which is nothing but P hat TV. Okay, so that's why this is wrong, and you should always write dou Cp by dou P at constant temperature. How to proceed? How to do my calculation? So if I want to do that, I'll start from this expression, which is dou P Cp by T at constant temperature, and which we can write as dou P dou S by dou T at constant pressure at constant temperature. Remember that this is nothing but dou S, dou P, dou T. So S is a thermodynamic property. With that, we can write this as dou T of dou S, dou P, T. Am I correct? Dou S, dou P, T. It is obtained from Maxwell's law. Fourth or third Maxwell, I don't know exactly. Which is minus dou V by dou T at fixed P. Which is dou T minus dou V by dou T at fixed P. And it is nothing but minus dou 2V by dou T square at constant V. So you got dou Cp by dou P at constant T. So this T will be coming out at constant temperature. So you get minus T dou 2V by dou T square at constant pressure. Am I correct? Dou Cp by dou P at constant temperature is minus T dou 2V by dou T square constant pressure. Am I correct? Yes. So similarly, we can calculate dou Cv at dou P, dou Cp, dou V. So all those things we can discuss in the next class. Thanks for your kind attention.